Hey everyone, and today I'll be going over epistasis with you all. Epistasis is the expression of alleles at one locus that masks or modifies the expression of other alleles at another locus. Therefore, this means that there are multiple different genotypes that are all being led to the same exact phenotype. It is important to note that an interaction between two different genes is not an interaction between alleles at one locus. Alleles are different forms or variations of the same gene. Gene that masks the action of another gene is epistatic to the masked gene. An example of epistasis, which we would do one of our own, is seen here. One of the 6 modes of epistasis that I will cover is single dominant epistasis. The dominant allele at one locus masks or modifies the expression of alleles at a second locus. If allele dominant A is epistatic to dominant B and recessive B, then dominant A with a blank, which this can be filled with another dominant A or recessive A, results in a particular phenotype no matter what is at dominant B or recessive B locus. This will therefore result in a 12:3:1 ratio in the F2 generation from a dihybrid cross, which results in these following ratios, which you can simplify by combining the 9 and 3 phenotypes together, which are these two right here. An example of a single dominant epistasis is if you breed my Issa brown rooster, Honey Boy, to my black Langshan hen, Henny Penny. We will get various sizes and colors from their chicks, as seen from the current offspring. Honey Boy is a rather large in size white and cream colored rooster. He has no feathers on his feet. Henny Penny is my smallest hen out of all the hens that I have. She is solid black and has the bonus feathers on her feet. These two have made some interesting variations out of all the other combinations of my roosters and hens. Based off of this pathway, if Henny Penny, which I gave her the enzyme B for black, which this blank can either be another dominant B or a recessive B, and the inhibitor here I'm giving is for the white gene or for the red gene based off of my other hens, and then the white intermediate is Honey Boy, and I gave him white, and the enzyme here is for the white, but he can't be recessive, an all recessive white. And based off of what they either made a solid black chick that looked exactly like its mother, or a smoky chick that wasn't solid white, but it had this very smoky or very white tipped. And based off of their crosses, which I automatically went ahead and did these two phenotypic here, it would result in a ratio of 12 black, 3 smoky, and 1 white. And then to give you a better illustration, I drew it out in this thing here, which I color-coded for you. And so, based off of this, you could have 9 dominant A with either another dominant A or recessive A, dominant B with either another dominant B or recessive B, followed by a 3 dominant A recessive A with 2 recessive Bs, which would equal your black, and then so forth and so on with your smoky and your white. But then I did another cross for you guys, and I did these two here, and based off of this, which I color-coded for you, if we did this, we would have 8 white, 4 smoky, 4 black, which this is not a dihybrid cross. Actually, if you simplify this, you would get 4:2:2, which is not a form of epistasis because it doesn't fit any of the modes of epistasis. And then these are my references.